there is a function in Excel called percentile. The first argument is the set of returns or set of data. It doesn't have to be a return data. And the second argument is what's the percentile? Well, 5%. Okay. And the second one, actually, let's make this 2.5 versus 97.5. So let me change these. That means in actual data, 2.5% of the returns are below negative 5.48. Okay. And 2.5% of them are above 4.92. We can kind of figure out how many standard deviations away are they. Well, let's number sigma below. So think of it this way. Let's figure out how to get that number. So I have a number, x, that's equal to the mean minus a times sigma, okay? And in this case, I want to know a. So x plus a times sigma, I'm sorry, a times sigma equals x bar minus x, a equals the average, sigma is standard deviation, and x in this case is the percentile below. So I want to know how many standard deviations negative 5.48 is below the mean. Going back to our formula, x bar is the mean minus the percentile I have divided by the standard deviation. So that's 2.16 standard deviations, okay? If it was normally distributed, that should have been 2. We're going to do the same thing for how many standard deviations above the mean. If we solve for b, it's going to be x minus x bar divided by sigma. That's my x. Where are you? Minus the mean. Okay. So that corresponds to 1.80 standard deviation. Just from here alone, you kind of know that data is a little bit left skewed. Left tail is longer. If we calculated the same amounts for these, overall, that kind of skew applies, but you know, it's a little bit different. Now, I'm not necessarily interested in these, just to show you that there's a significant amount of chance that in 1 week you could lose about 5.5% of your portfolio. Okay, that is not small. And if I wanted to do 1 in 99, there's about 1 in 100 chance that in a week you could lose 7% of your portfolio. So yes, we look at the returns, but there is significant risk in these investments as well. Let me move these two. But on the other hand, look at the bond portfolio. Outside of that 1% chance, you're not going to lose more than 1.6% in a week. Gold is riskier than that. On the other hand, there's a portfolio of them which doesn't necessarily give a bad return, but the risk, in a sense, as measured by these, is much less. So we kind of need an idea about what sort of portfolios, at a minimum, one should hold. First question to ask: what is the minimum requirement for a portfolio to be held? For that, we're going to define the concept of an inefficient portfolio. A portfolio is inefficient if there exists another feasible portfolio that has higher reward, however you measure that reward, such as the average return or expected return, and lower risk. Again, however you measure that. For our illustration purposes, we're going to measure rewards with historical average return and risk with historical standard deviation. I'm going to do everything we're going to do using those, but when I give you guys a group homework about this, you're going to use different measures. but the lessons are going to be the same. All right, let's go to our sheet. Okay. We're going to ask ourselves the following question. Suppose I require that